For the word problems about maximum or minimum cost or time or height or whatever, they're still going to give us a quadratic function. And since we're talking about a max or a min, we're still looking for that vertex. The only thing to figure out for most problems is, do they want the x value of the vertex or the y value of the vertex? And that's really just about reading the problem carefully and making sure you know what everything stands for. So in this problem, they tell us that they're making some machines and the number of machines affects the cost. They use x to represent the number of machines being made, and then c is the cost. C is usually what the y value would be. Like normally you'd see a y over here. So in this question, they're saying, what is the minimum cost? To find that, I want the y value of the vertex. But of course, before I can find the y value of the vertex, if it's in standard form like this, I need to find the x value. So I'll do the normal things. X value of a vertex is the opposite of b over 2a. So in this case, the opposite of b is going to be 240. And then 2 times a is going to be this calculation, which should come out to be 200. That means that's how many machines we'd make if we want to minimize costs. But I actually want the minimum cost. So I'm going to take that 200 machines and plug it into this function. 0.6 times 200 squared minus 240 times 200 plus 35,581. Plugging all that stuff into a calculator is going to give me a value of $11,581. They're talking about throwing a ball up in the air, and its height is given by h, and we want to know what's happening after t seconds. So the way this problem is set up, you can see that t is usually in place of where the x would be, and the height's in place of what y would be. And they want to know, how long is it going to take to reach the maximum height? They're not asking for the maximum height. They want to know how long it's going to take. So that's going to be a t value, which of course is in place of what our x usually is. So since it's a max-min problem, we're still looking for the vertex. And they want to know when it reaches that maximum height. So they want to know a time t. So I'll just, again, use that formula, opposite of b. But in this problem, they did try and mess us up a little bit by putting the a value second and the b value first. And if you're not sure why that happened, keep in mind a is always what's in front of t squared, and b is always what's in front of just the t value. So to find when it reaches its maximum height, I'll take the opposite of b, negative 48, over 2 times a. And then if I put all this stuff in my calculator, or if I rely heavily on my awesome knowledge of fractions, however you look at it, you should get 1.5. So after 1.5 seconds, the ball will be at its maximum height. I can stop here because I don't actually need the height. I just want to know when it happened. So just if you read the problems carefully and you know what x and y are standing for, and you know you're trying to find a x or y value of the vertex, these are no more difficult than like anything else we've done. It's just easier to psych yourself out. Don't psych yourself out. Be awesome at it.